In this video, we're going to talk about the calorimetry of phase changes, and we're going to look at the energy inputs required to bring a block of ice at negative 10 degrees Celsius all the way to steam at 115 degrees Celsius. So first off, changing the temperature of a substance, you add energy, temperature goes up. It's not the same at every phase. So for ice, for example, it takes 2.09 joules to raise a gram of water 1 degree Celsius, whereas for water, it takes 4.184 joules to raise its temperature 1 degree Celsius for every gram. And then steam, it's less. It only takes 1.85 joules to raise a gram of steam by 1 degree Celsius. So in going from negative 10 degrees Celsius and raising the temperature of that block of ice to the point where it's going to melt, you can see that we're going to use our equation Q equals mc delta T to figure out the energy change associated with that. So since we have a 20-gram block of ice, we're going to use that as the mass. The specific heat of ice is 2.09 joules per gram d Celsius. And then we're only going up 10 degrees as a solid. Once we get to that 10 degrees, however, you're going to be able to add energy to it without seeing a change in temperature. So what does that mean? When you have temperature is defined as the average kinetic energy of the molecules in a sample. So as you raise the temperature of the block of the ice, you're adding kinetic energy. And we can use this equation because we have a temperature change. But melting ice is going to happen without any temperature change. So you're adding energy, but the temperature doesn't rise. Therefore, we're going to say that that energy is going towards increasing the potential energy of the H2O molecules as we go from a solid to a liquid. So we have to account for that input. And for water, we can see that that takes about 333 joules to melt a gram of ice with no temperature change. So to figure out that energy, we just say we got 20 grams of ice, takes 333 joules per gram. So that takes 6,660 joules to melt this block of ice. Then once it's all melted, we continue adding energy. And at this point, since it's all liquid, you're going to be raising the temperature. So we're going to go from 0 degrees Celsius, and water's boiling point's 100 degrees at 1 atmosphere. So figuring out how much energy that's going to take, again, we just use the mass for M. The specific heat of water is 4.184 joules per gram degrees Celsius, and then 100 degrees Celsius is our temperature change, and you can see that that is the energy that would be required for that. Then, once you get to 100 degrees, okay, you're still adding energy. If you put a thermometer in boiling water, it's going to stay 100 degrees, even though you're continuing to add energy. Now, why does it take so much energy? We see that water takes about 2,260 joules to basically get a gram of liquid water to become vapor. And in comparing the heat of fusion versus the heat of vaporization, we see it takes way more energy to go from a liquid to a gas than it does from a solid to a liquid. That's because when you have solid water, you have fixed positions, they're just vibrating. Adding energy is just going to make them vibrate faster, but at some point, they have to be able to overcome their intermolecular forces, their hydrogen bonding, to be able to become a liquid. And that change is going to increase the potential energy. That energy required to overcome that static arrangement is going to be what we see in the heat of fusion. However, going from a liquid phase to the gas phase, we have to completely overcome those IMFs and separate. So that's why the heat of vaporization is significantly higher than the heat of fusion. Now, we've added enough energy to make that happen. That's at 45,000 joules. And we're going to see that out of the total, that's a huge percentage of the energy required for this process. But then, once it's all steam, if we continue to heat it up another 15 degrees, then you're going to see 20 grams times the specific heat of vapor times the change in temperature, and we get 555 joules. So if we're calculating the total energy for this entire process, we would just have to add up all of these pieces. The energy to heat the steam, the energy to evaporate the water, boil the water, to raise the temperature of the water, to melt the ice, and then to raise temperature of the ice. And we get that that would all add up to 61,200 joules.